When? Uh, yeah, you will need. So we've got this y equals 210, 3x minus pi and 4. Now, that's our domain, pi and 12 to 11, pi and 12. Now, it is a tan graph, so what's our period going to be, Maya? Pi on 3, it is correct, pi on 3. Okay, so that 3 is simply that 3 here. Now, we can rewrite this another way. Does anyone know what we can do to this to sort of make the transformations a bit more evident? What's something that we can do in here that will help us? You can cheat by looking at the notes there you've got in front of you. What we're going to do is we're going to factorize out. We're going to factorize out our 3. By doing so, because 3 times x is 3x, and 3 pi on 12 is the same as a quarter. This is shifting to the left or to the right? Right, by pi on 12. Okay, so as we do that, that's something to think about. Once again, you've got to play around with your asymptotes and intercepts. So 3 things for 10. Period, asymptotes, intercepts. They're the 3 things to do. Okay, so please remember that for asymptotes, that's our count. Okay, but our n is our 3. But the reason why we factorize a 3 is we look for the shift, the real shift. There's a shift in there, but this is the real one because now x is by itself. So it's being all our asymptotes, all our dotted lines are not sitting on our zeros. They're now shifted right by pi on 12. So if we keep going further, we have that. How do I combine these two together? What do I need to do, Zach, to this? I want to join these fractions together.
We need the same number on the bottom.
Same number on the bottom. Okay, so if I have a 12, what do I need to do on top to keep it as a ratio between 1 and 6?
Need to double the top.
Need to double the top. Thank you. Like so. Okay, and then you keep going so that make sure you've got your counting system there. And we know that Z is simply, Z? Integers. Okay, thank you. Okay, so if we keep going, I've got a 4k plus 2 on the left. If I keep going here, I can take the pi and 12 out. Okay. And what needs to go into bracket to make this correct once again? I factorize a pi out of 12. What needs to come into here to make it reset? Well, to make it the same as that. Nathan, any ideas? 4k plus? Good, 3. Because there is a 1 over here. Make it ended. Okay, so this is what helps you count. Let's do one for the intercepts. Who remembers what's the equation for intercepts or tangents? Sorry? Not quite. It's got a K in it too. K. That's okay. K pi on n. Okay? Which is the 3. But what must we do to this? Okay. Based on our equation. That's okay. Does anyone know? Okay. Keyword is shift. Plus pi and 12. Okay. Always look at what's happening in our equation. Okay. How do I turn this into a fraction so that we can join the two fractions together, Perry? What would we do to this? Times it by 4. Thank you. And if I grab pi out of 12 outside, Emily, how would I complete this? 4k plus 1. Okay. So let's now go to the graph. You can see that the smallest fraction that's sort of operating is pi on 12. So we use that as our gaps, as our increments. 1. Let's go. 1. Don't want to go too far. 1, 2, 3, 4. 8, 9, 10. Let's go with that. So I've got a pi on 12 over here. But now, we're going to use our counting system to figure out where our asymptotes are lying. So I could go k equals 1. If k equals 1, what does that become? 7 pi and 12. If k equals 2, what does that become? 7 pi and 12. 11 pi and 12. Thank you. Okay. So now, I've got to look for a 7 pi and 12 and an 11 pi and 12. So 1, 2, 3, 4, 5, 6, 7. That's an asymptote. And now look for my 11 pi and 12, which should be about here. We can also, just by looking at our boundaries, pi and 12 to 11 pi and 12, just by visually looking, we can see that there's another asymptote happening somewhere else. We can do it a few ways. How can we know where the next one is coming on the left? What could you do? Okay?
Yeah, k equals 0.
K equals 0. And if k equals 0, we have 3 pi and 12. What's another way of getting this last asymptote? Anyone know? Sorry, Mike. You can go k equals -1. That might go over. But having a look at the boundary line, you can see that we're going to stop here. So that's still a good point though. You can go k equals -2 if it's required. The other way is simply looking at the gap 1, 2, 3, 4. You just repeat the pattern until you hit your boundary from the top. Okay? All right. Let's do some counting over here. Let's do k equals 0, see if that gives us anything. K equals 0, Perry, k equals 0, what do we get? 1 pi and 12 equals 1, Zach. What do I get? 5 pi and 12 equals 2, Tim. Let me skip there. Sorry. 9 pi and 12. And let's look for these. So k equals 0, pi and 12. So over here, that's 1. I look for 5. I go 1, 2, 3, 4, 5. What's the other way of, if you've got 1 already, or you don't even need 1, what's the other way of looking for an intercept? The middle of the asymptotes. Thank you, Maya. They're all sitting in the middle. Okay? Even if it's just left or right, all the asymptotes are doing line dancing. They all like to line up nicely. Okay? So we'll do this. Because it's a positive, swing, swing, up and down. Get it, you text it. And remember, this is a sketch. Over here, we stop at pi and 12. But don't go further down. Over here, this is 11 pi and 12. So this is still included. That's never going to cross 11 pi and 12. Any questions? Okay, there's many ways to graph a tan graph. It just depends on how your brain works. But you must show working out when required. Let's do some solving. What's the whole idea of solving? Nathan, what's the whole idea of solving? What are we trying to do? Finding the value of x. Okay, so we're gonna, what's a good step, Gabe? To start with this.
Start by dividing by root 3.
Start by dividing by a root 3. Okay. What's also a good idea to set us up for success in this question, Maya? Replace the 3x? Oh, with an A? Okay, we can. But it might go on a tangent. I would leave it, Maya. 1 on root 3. Where have you seen that, Maya? In the triangle, which one? Yeah. Which there's 2. Got the 2. Okay, so the 2, remember, is the equilateral triangle that we have. Therefore, if we have that, Maya, what's down here? 1. And what is here? It's a root 3, yeah. Okay. Because it's an equilateral triangle, this angle here is a 60 or pi on 3. 30 pi on 6. Okay, so we need that. Therefore, Emily, what's my next step?
To do tan negative 1.
Tan negative 1 technically is an inverse, but I'll. Oh, okay. Oh, it might be down for that. Inverse of a 1 on root 3 Zaid. What is that going to be according to here?
What angle are we looking at again? Hold on.
This here, I want an opposite over adjacent. The opposite has to be a 1.
Oh, so it would be the 30 degrees.
It'd be the 30 degrees. I think it is. It is. That's a pi on 6.
Because we're working in radians.
Yes, and we're working in radians. Good. Thank you, Zane. Now, what else is the other thing that you need to memorize in addition to the triangles? What's helpful for us? Perry. The unit circle, thank you. Which one are we interested in, Zach?
2 and 4.
2 and 4. This is 1, 2, 3. Which letters?
Well, we want to. Oh, no, we want to cover it.
Yeah,
So 1, 3.
1 and 3. Thank you. Good. Okay. So I've got a pi on 6. Pi on 6 is not the only answer. What's another answer, Nathan? This is pi on 6. What's this one here? 7 pi on 6. Are those the only 2 answers? And if it's a no-go, why? What? Why go? Okay. There's more solutions here. And this is a common thing students can miss. If this is a 3, if n is a 3, what needs to change with our domain? Times it by 3. Got to times it by 3. So therefore, got to go a few more times. 1, 2. This is 2 pi. What's this one here? The next time round, one round. Second time round, what's this? 30 pi 6. What's the next one, Tim? This one here? The third one? The fourth one?
No, you won't.
Oh, my bad. My bad. Yeah, got it. 19 pi 6. Okay. Do we stop Zaid or do we keep going? How many times have I spun my wheels?
2.5 rings.
Yeah, about 2.5. We need to get up to 6. So we've done 2, we've done 4. Okay, so we're up to 4 pi now. So what's this one here? If that's 4 pi, what's the next one? Which is 4 pi is the equivalent of what on 6? 4 pi.
24 and 6.
Good.
So that'd be 25 and 6.
Exactly. Okay. What's this one, Perry? That's 24 pi. It's getting a bit tricky now. The fractions are getting higher. Remember, this is kind of like a 3. That's 4 pi. Now, this is 5 pi now. We're up to 5 pi. But we want it on 6. Good. So our reference here is a 30, which makes this a 31. Thank you. Last step. Zach, last step. What's our last step?
Like simplifying it?
Yeah. Yes or no? Not sure what you're saying.
I don't really know.
That's okay. How do I get x by itself? Divide by 3. It's a lot of work.
fine if we answer with improper fractions.
Yes, it is. It's mostly accepted. You don't want to do mixed numbers here. Okay. Any fraction that you can see that can be simplified do need to be simplified, and you can't with these ones. Okay. All right. I'm going to skip that one. Oops. Because it's pretty similar, but I want to do the last. Let's skip to the last one. Any other questions? Okay, last example for today. Something's a bit different in this one. All right, let's reset this. Okay. Nathan, what's my period in here? It's just pi. Good. Okay. With that x-axis intercepts, like in a graph, we had a counting system from before. We can do that. The other way is to treat it as a normal graph to get your x-intercepts, the normal process. So if I'm trying to find an x-intercept, what am I going to substitute in?
0.
Where?
No. Only 1.
No. Okay. What's my next step, Emily? Minus the root. Okay. And we go like so. Now, hopefully I haven't made a mistake here. I've made a mistake in the question. My bad. That should be here. Therefore, this is a pi on 2. Okay, my bad. Okay. Given that the 2 is now inside, what's my next step to undo my? That's okay. I've got a 10, a 2x. If there's no attachments in front, we can go straight to the tan. So if I want to move the tan out, what does it become on the other side? A tan inverse. Okay. Now, it looks like I've missed something. Looks like I've missed the negative. But how do we account for negatives again, Gabe? What do we do? How do I calculate negative values for our tan? What helps us on the side.
Oh, you put it in the different parts of the line. So in X or Z.
Okay, so if I want an inverse tan, you said in the S and the C. That's what we want. Okay. It's got a root 3. I rubbed it out. So I'll write it again. It's good practice. That's true. Inverse of a root 3, say inverse of a root 3. Remember, that's a root 3, but it's over a 1 as my clue. What angle is it operating in that?
The 30-degree angle. The
Yes,
5 and 2.
The pi on 6. Is that right? It's a pi on 3. Okay. So from here, opposite is a root 3. Adjacent is a 1. So that's root 3 on 1. So we're going from the pi on 3. Okay, so I'm just going to rewrite this on the other side. So pi on 3 here is our first one. I know these are pi's and 3's. Okay. Do I need to change my domain at all?
Yeah.
We do. What does it become?
I'm playing and version pi 3. No, because you
Okay.
want.
If there's a 2 in front,
So it'd be pi on 12.
pi on 12.
Yeah,
Okay.
pi on, and 26 pi on.
Yeah.
Pi function.
Okay, so 2.
So we try for 2. Yes. So I was doing it. Oh wait, no, because
That's
it'd be 13.
2 pi on 3. Should that be pi on 3? Yeah. Hopefully I don't lose it.
Are we multiplying with the new?
2 times pi on 6. That should be pi on 3, I think. I'm hoping. We'll see if I've done that
so then
correctly.
the upper one.
226.
13 over 3.
30 pi on 3.
We're multiplying the whole thing.
26. I'm going blank at the moment. We'll come back to that. So, I just hope I don't. That could be wrong. I'm probably wrong. I got the feeling I'm wrong. I just can't think at the moment. But let's go back to this. What are my answers, first of all? Okay, so that should be a 2 pi on 3. Yeah. You do one full circle. That's a 2 pi take away pi on 3. And what is that? 5 pi on 3. Okay. Now, we need to keep going a few more times. When you go, you'll see why anyway. If I go the second time round, what's this? If this is now 3 pi, we go 3 pi back. 18 pi and 3. 17 pi and 3. I hope I'm right. I'm wrong. Sorry, I'm losing you guys today. 2 pi and 3. I'm losing it.
Oh my god, what the heck?
It'll be 8 pi and 3. My bad. 8 pi and 3. And the next one is 11 pi and 3. Sorry. I'm losing. Hey, Manny. I'm losing my focus. Okay. Now, what do I need to do now, Nathan? Back to x by itself. What do I undo first? The 2. Okay, so this is 2 pi and 6, 5 pi and 6, 8 pi and 6, and 11 pi and 6. Okay. Then, to get x by itself, what's the last thing that we need to undo, Tim?
Minus pi 4.
Minus pi and 4. On the other side it becomes?
Plus 1.
Yeah, plus pi and 4. So I'm just going to simplify these where I can. 8 pi and 6 should be 3 pi and 2. No? 2, 4, 4 pi and 3. 11 pi and 6 I can't change. Then I'm going to add. There's a lot of fraction work here. Pi and 3 plus pi and 4. 5 pi and 6 plus pi and 4. 4 pi and 3 plus pi and 4. And 11 pi and 6 plus pi and 4. Okay. I'm going to erase this. Get more space. Pi and 3 plus pi and 4, good common denominator, Gabe. 12s. Okay. Okay. 6 and 4, what's a good common denominator, Maya? 12. Good. You can do 24, but that's too much work. I've got a 12 on here. What do I need to do to the 5 pi, Emily? Times it by 2. I've got a 12 on here and a 4 here's 8. What do I need on top to make it back to a quarter?
Oh, I wasn't focusing that part.
That's okay. 4 turns into 12. What did I times it by?
No, 3.
3. So I need 3 up here. Okay. These are 12s. Okay. Manny, 3 turned into 12. What is going to be on top?
16 pi.
16 pi. And this one here? What should be up here? 3 pi. Perry, help me out with this one here. 11 pi changes to 22 pi. And the next one? 3. Okay. Hopefully we're correct. Now I just put them together. 7 pi and 12. 13 pi and 12. 19 pi and 12. Sorry, Missy. And a 25 pi and 12.
What's the point of simplifying it when you're just going to change it both later?
That's just when my brain works. Sorry. Which part? Which simplifying part? Here?
It's not like 2 pi and 6 and 2 pi and 3.
Yeah. I've got to, for me, I've got to do the in-between steps. Okay. If you don't need to, you don't need to. Okay. So, having a look at our intercepts. 7 pi and 12. Now, For me, the reason why I want pi and 12 is it creates that our increments on our graph. So if we look here, that's my pi and 12. If I've got x-intercepts, I can just count 7 times. 1, 2, 3, 4, 5, 6, 7, 30, 8, 9, 10, 11, 12, 13. And I'll go a few more. Okay. 19 pi and 12, 13, 14, 15, 16, 17, 18, 19. We need one more. Another 6 to go. It's messy. That's by 25 pi and 12. Hopefully. 19, 20, 21, 22, 23, 24, 14. That's good. Okay. As you can see, our last intercept fits into our change domain that we had to recalculate. Okay. All right. Where's my asymptotes going to go? If you do it the quick way, 1, 2, 3, 4, 5, 6. It sits nicely. 1, 2, right here. I'm just going to halve. Just like you can halve the asymptotes, you can halve the spaces in between x-intercepts. Okay. Like so. Okay. Yeah, we go. It's this. Yeah, I made a mistake because that's not right. Let's do it properly with that asymptote calculation because this is different. It doesn't sit symmetrically. Let's do the proper counting. Now remember, we always start with our counting. The mistake I've made is I made an assumption. And you'll see why when we finish our graph, why my assumption would have led to an incorrect graph. Always start, just a reminder, just start with your routine. Don't try and think too far ahead. Don't try to assume like I just did. Exactly. So Tim's picked up something. This root 3 has shifted everything up. So not, if I shift a normal tan graph, if I shift it up, it goes something like that. It now doesn't sit nicely on a graph. That's when that's there. If you've only got this section here without any translations up or down, you're sweet. You can assume symmetry. You can't do it when you start moving the graph up or down. So if I start off with my counting, I know that these asymptotes are shifting by how much to the right by looking at our equation. It's a pi and 4 that you can see in there. Our n is a 2. So we've got that happening there. Okay? Therefore, if I want to put them together, I can factor out the pi and 4. What goes in the bracket?
2k plus 2.
The 2k plus 2. Because that's a 1. 1 and 1 make the 2 with the 2k. So now let's chuck in some counts. K equals 0. If k equals 0, what do I have? Pi on?
Pi on 2.
A pi on 2. K equals 1. 2 times 1 plus 2.
Pi on 4.
Pi and 4? Or 5 pi and 4? 2 times 1 is 2 plus 2. It's a
4 pi on 4.
It's a pi. I was wrong. You were wrong, mate. And I was wrong. K equals 2. 2 times 2 is 4. 4 plus 2 is 6. 6 pi on 4 is?
3 pi on 2.
Or 3 pi on 2. Okay. We do that. Let's go over here to our asymptotes. Let's look for a pi on 2. But I want it just to make it things easier for ourselves. Our increments are in 12.
6 pi on 12.
So 6 pi and 12 is our first asymptote. I go over here. 1, 2, 3, 4, 5, 6. Hopefully I haven't stuffed that one up too. 1, 2. Okay, here. 1, 2, 3, 4, 5, 6. Right there. I was missing a dash. Okay, if I want a pi, but it's out of 12, I want a 12 pi and 12. Okay, 13, 12, 13, 12. What's the pattern?
12 plus 2.
Sub by 6s, yep. 6 spaces.
Yeah.
And for every intercept, the asymptote is?
1 pi on 12 behind.
1 pi and 12 behind. You can see it there clearly. So you can, once you figure out the pattern, you can just whack it in. Okay, almost there, guys. Now, one thing to note. Let's just say this is about root 3. That's root 3. But if I look here, the middle of our tangent graph is on 0, 0 originally. But it's shifted pi and 4 and up root 3. What am I saying?
The midpoint is 6 pi, so root 3 and
Yeah.
midpoint. I suppose.
As Tim said, our 0, 0 in the tangent graph is now no longer at 0, 0. It's shifted pi and 4, which is a 3 pi and 12 at root 3. If I go over here, 1 pi on 12, 2 pi, 3 pi and 12, right here. That's the middle of our first tangent section. Pi on 4, root 3. Then, from our middle, we do a tan graph. And it works. If I go like that, look carefully, nicely, goes down. Okay? And you keep repeating that like so. And it gets messy if you're sketching. But remember, these are sketches. It's a lot of work. Last thing, be careful about the ends. We can see through the pattern, it's going down, but you must stop there. I wiped it off. It stops at 26 pi on 12. make sure you indicate whether it's closed or open. In this case, it's closed because we had a less than or equal sign whacked in there at the domain.
So what is the domain?
The domain, it's originally it was 13 pi on 6 to pi on 6, but we have to times them by 2 because of this 2 here. So it's a 26 pi on 6.
So it's 52. Try to get 12.
It should be 20.
Oh, okay.
Oh, sorry, my bad. 26 pi on. That should be right. 2.
Oh,
If I times 13 by 2, it's
you've
26.
been counting on 12.
Yeah, I'll be counting 12. Oh, let's see if I 26 pi on 2.
Yeah, that's what we did.
Maybe I got it wrong. I could be wrong. 12. Let me think about that. I think I'm wrong. Maybe
You
not.
make the sax 3.
Huh?
You make the sax 3.
I get them checked with Mr. Cantwell. We all make mistakes, Tim. Okay. Okay.